Welcome to the deep dive. You know that feeling when your phone seems to know exactly what you want next.
Oh, yeah, uncannily sometimes.
Right. Well, today we're diving into the tech behind that magic recommender systems. They're like these hidden engines online, figuring out what we might like.
Exactly. Products, movies, news, they sift through just vast amounts of data to give us those personalized suggestions.
So our mission for this deep dive is really to unpack how they work. We'll look at the different types, the challenges they run into, and maybe where things are headed. We're using the recommendersystems.pdf document to guide us.
And for you listening, understanding this stuff, it's kind of like getting a peek behind the curtain of your own digital life.
Right. Why do I keep seeing ads for that specific thing?
Precisely. It helps make sense of why you see certain content, certain ads, those curated music playlists. It helps you see how your online world is shaped and maybe navigate it a bit more consciously.
Okay, so let's start with the absolute basics, the building blocks. You've got users, that's us looking for stuff.
Yep. And then you have items, the movies, the songs, the products, whatever's being recommended.
And the key thing connecting them is interactions, right?
That's the glue. Interactions are basically everything we do online that leaves a trace. They tell the system something about our preferences.
Okay, so interactions, like there are different kinds.
Yeah, broadly two types. First, you have explicit interactions.
Yeah.
That's when you actively tell the system what you think.
Like giving a movie 5 stars or a thumbs up.
Exactly.
Yeah.
Ratings, reviews you write, clicking like or dislike, maybe filling out a little survey after you buy something. It's direct feedback.
Gotcha. Clear signal.
Then there's the other kind. Implicit interactions. These are more subtle, based on your behavior.
So like what I click on or how long I watch a video.
Clicking links, browsing history, purchase records, how long you hover over an image, even skipping a song quickly. It's all data.
So implicit feedback is like always happening. We don't even have to think about it.
Pretty much. It's abundant, which is great for the system, but it can be harder to interpret.
Yeah, like did I pause that video because I loved that scene or because my doorbell rang?
Exactly. That ambiguity is a challenge with implicit feedback. Explicit feedback is clearer, but, fewer people take the time to actually give it.
Right. So the system takes all this feedback, explicit and implicit.
And uses it to figure out your likely ratings or assessments for things, and ultimately, your underlying preferences. This whole stream of data, good or bad, is the feedback loop that helps the system learn and get better. It's constantly trying to adjust.
Okay, that makes sense. Users, items, interactions, feedback, got the core pieces. Now, how do these systems actually make the recommendations? Our document mentions content-based filtering first. What's the elevator pitch for that one?
Content-based is, well, think of it like suggesting things directly similar to what you already like.
Yeah.
It focuses on the characteristics, the content of the items.
So if I watch a lot of, say, sci-fi movies directed by a specific person.
Exactly. The system notes the features genre sci-fi, director X, and then looks for other items, other movies, that share those same features. It recommends based on content similarity.
And these features or attributes, what are they typically?
It really depends on the item. For a movie, it could be genre, actors, director, keywords from the plot. For a song, maybe genre, artist, tempo, mood. For news, keywords, topics, publication source.
Right, so the system profiles the items based on these features.
And then it builds a profile for you based on the features of the items you've liked or interacted positively with in the past.
Okay, and then how does it connect my profile to new items? Is it just matching keywords?
It uses something called similarity measures. Algorithms, often things like cosine similarity, mathematically calculate how close your profile is to an item's feature profile.
Ah, okay, like measuring the distance or angle between them in some kind of feature space.
That's a good way to think about it, yeah. The closer the match, the higher the recommendation score.
So where do we bump into this content-based stuff day to day?
Oh, lots of places. News websites suggesting articles on topics you read often. Music streaming like Spotify, suggesting songs in genres you listen to. Ebook platforms suggesting similar authors or themes.
Even e-commerce, like if I buy hiking boots, it shows me tents.
Could be, yeah. Based on attributes like outdoor camping gear. It matches item characteristics.
Okay. What are the big plus points for this method?
Well, a big one is doesn't need other users' data. It's all about your interactions and the item descriptions. So it can recommend brand new items instantly as long as they have descriptive features.
Ah, so no cold start for new items.
Right. And the recommendations are very specific to your taste profile. Plus, they're often easier to understand. You can usually see why something was recommended. Because you liked X.
But it can't be perfect. What are the downsides?
Well, it can kind of keep you in your own bubble. Because it recommends things similar to what you already like. It might struggle to suggest things from totally new categories you might enjoy. Limited novelty, you could say.
Yeah, I can see that. You might miss out on discovering something completely different.
Exactly. And it's really dependent on having good descriptions or tags for the items. If the features aren't well defined, the recommendations won't be great. It also still has a cold start problem for new users. If you just signed up, it knows nothing about you.
Right. No history, no recommendations. And you mentioned novelty. It lacks that element of surprise, maybe, serendipity.
It often does, yes. It's less likely to give you those happy accidents because it sticks close to your known preferences.
Okay, so if content-based keeps you in your lane, what's the other main approach? The document brings up collaborative filtering. Sounds different.
Totally different philosophy, yeah. Collaborative filtering works on the principle of people like you also liked. It doesn't care much about the item's content. It looks at user behavior patterns.
So it finds people who have similar tastes to me.
Essentially, yes. It leverages the community's wisdom, you could say. If you and another user have rated several movies similarly, the system might recommend a movie that the other user loved, but you haven't seen yet.
Even if that movie seems totally unrelated, content-wise, to the ones we both rated.
Precisely. The connection is the shared taste pattern, not necessarily shared features.
Interesting. And there are different ways to do this, user-based and item-based.
Correct. User-based collaborative filtering finds users similar to you, your neighbors, and recommends items they liked.
Okay.
Item-based collaborative filtering looks at the items you've liked and finds other items that are frequently liked or purchased by the same people who liked your initial items. Then it recommends those similar items. It's often more scalable than user-based, especially with huge numbers of users.
How does it figure out who's similar or which items are similar in this context? More math.
More math? Yes. Similarity measures again. For user-based, things like Pearson correlation or cosine similarity compare rating vectors between users. For item-based, they often use something like adjusted cosine similarity, which accounts for users having different rating scales. Some people rate higher than others generally.
Okay, so what's the big draw for collaborative filtering? Why use this approach?
A major advantage is domain independence. It doesn't need to understand the items, just how users interact with them. So you can apply it to movies, books, products, almost anything.
Ah, okay. Doesn't rely on good item descriptions.
Exactly. And crucially, it can lead to novelty and serendipity. It can recommend items that are completely outside your usual content bubble simply because people with tastes similar to yours happen to like them. Those unexpected gems.
That sounds pretty powerful, but I'm sensing a but coming. What are the catches?
Yeah, there are definitely challenges. The cold start problem is a big one here, too. New users with no interaction history. Hard to find similar users. New items with no ratings. Hard to recommend.
Right, the same issue from different angles.
Yep. And scalability can be tough, especially for the user-based kind. Comparing every user to every other user gets computationally very expensive very fast.
Millions of users. Yeah, I can see that.
And then there's data sparsity. In most systems, any given user has only rated or interacted with a tiny fraction of all available items. This makes the user item matrix very empty, which makes finding reliable similarities difficult.
So lots of gaps in the data. Makes sense. Okay, so we have content-based, which is personal but maybe too narrow, and collaborative, which finds novel stuff but struggles with newness and sparsity. Neither is perfect.
Pretty much sums it up, which naturally leads to
hybrid approaches, combining them.
Exactly. Hybrid systems try to mix and match different techniques to get the best of both worlds, leveraging the strengths of one method to overcome the weaknesses of another.
So like using content-based to help with the cold start problem in collaborative filtering?
That's a classic example, yeah. Recommend new items based on their features initially until they gather enough ratings for collaborative filtering to kick in. Or use demographics for a brand new user's first recommendations.
How do they actually combine these methods? Is it just averaging scores?
There are several ways, as the document outlines. Weighted hybrids assign weights to recommendations from different systems and combine them. Switching hybrids use one method in certain situations, like cold start, and another method otherwise.
Okay.
Mixed hybrids might show, say, content-based and collaborative recommendations together in the same list. Feature augmentation is clever. It uses output from one system as input features for another, like using content features to enrich a user's profile for collaborative filtering.
Feeding data between them.
Right. And meta-level hybrids use one recommender's output as the input training data for a second-level recommender, kind of like a refinement step.
Wow, okay, lots of ways to blend them. Now, the document also mentions a couple of others, knowledge-based and demographic filtering. Are these common?
They have their niches. Knowledge-based filtering isn't really about past behavior like the others. It uses explicit knowledge about how item features satisfy user needs, often involving asking the user specific questions.
Like for complex purchases,
Got it.
cars, or financial products.
Exactly. Things where specific constraints and requirements are key, and maybe interaction data is scarce or less relevant than current needs. It relies on deep domain knowledge.
And demographic filtering.
Demographic filtering is simpler. It groups users based on demographic info, age, location, gender, and recommends items popular within that group.
So kind of basic segmentation.
Yeah. It's not very personalized, but it can be a starting point if you have absolutely no interaction data for a user.
Yeah.
Better than random guessing, perhaps.
Okay, got the landscape of types. Now let's talk more about the challenges. We've hit cold start and data sparsity a few times. How bad are these in practice?
They're persistent problems, especially in very large systems. That sparse user item matrix means algorithms can struggle to learn effectively, and they might end up just recommending popular items all the time because those are the only ones with enough data.
So it biased towards the mainstream.
It can, yeah. Mitigation often involves techniques like dimensionality reduction or using latent factor models, which try to find underlying preference dimensions even with sparse data.
And we mentioned scalability. As systems get huge, Netflix, Amazon, how do they cope? It must be computationally massive.
It really is. Calculating recommendations for millions of users and items in real time or near real time is a huge engineering challenge. The latency, the delay before you get a recommendation has to be low, or users get frustrated.
So what's the solution? Just bigger computers?
Well, yes, but also smarter techniques. Distributed computing frameworks like MapReduce or Spark are often used to parallelize the calculations across many machines. Also, using more efficient algorithms, sometimes approximation techniques that trade a tiny bit of accuracy for a lot of speed. Item-based CF, as I mentioned, often scales better than user-based.
Okay, beyond just the technical hurdles, what about the quality of recommendations? Is just predicting clicks or ratings enough?
That's a great question. Increasingly, the field recognizes that pure accuracy isn't the only goal. Users also value things like diversity, novelty, and serendipity.
Right, we touched on those. Can you elaborate a bit? Like diversity?
Diversity means recommending a good mix of items, not just 10 variations of the same sci-fi movie, but maybe including a related documentary or a book by the same author or something from a different but potentially relevant genre. It broadens horizons.
And novelty and serendipity, finding things I wouldn't expect.
Exactly. Novelty is about recommending items that are genuinely new or unfamiliar to the user, things they likely wouldn't have found on their own. Serendipity is that special case of novelty where the unexpected item turns out to be surprisingly relevant and delightful. It's that, wow, how did it know I'd like that moment?
Those definitely sound like they make the experience better. How do systems try to inject more of that? Just randomness.
Sometimes a bit of randomness helps, yeah. But also specific algorithmic tweaks. Promoting diversity might involve intentionally selecting items from different categories. For novelty, maybe downweighting things that are too similar to recent interactions. Serendipity is harder to optimize for directly, but analyzing feedback loops can help identify patterns that lead to it.
Okay, one more challenge mentioned, overfitting and underfitting. These sound like machine learning terms.
They absolutely are, and they apply here too. Overfitting is when your model learns the training data your past interactions too perfectly, including all the noise and quirks.
So it doesn't generalize well.
Exactly. It might recommend things based on accidental patterns in your history and fail badly when your tastes shift slightly or on new items. Underfitting is the opposite. The model is too simple, it doesn't capture the real patterns in your preferences, leading to poor generic recommendations.
How do you avoid those traps?
Standard machine learning practices help. Things like cross-validation to test the model on unseen data, regularization techniques to prevent the model from becoming too complex, and just careful model selection and tuning.
Right. Balancing complexity and generalizability. Okay, so let's shift gears and look forward. What are the big trends shaping the future? The document emphasizes AI and machine learning.
Yeah, AI and ML are fundamentally driving progress. We're seeing much more use of deep learning, complex neural networks that can find really subtle patterns in huge data sets. This often leads to more accurate recommendations, especially for things like image or sequence-based recommendations like video suggestions.
What about understanding language, reviews, descriptions?
That's where natural language processing, NLP, comes in. It's getting much better at extracting meaning from text, so systems can understand user reviews, analyze item descriptions more deeply, and even power.
Conversational recommenders, like talking to the system.
Exactly. That's an emerging trend, using natural language dialogue to refine recommendations. NLP is key there. And another technique gaining traction is reinforcement learning, RL.
How does RL apply here?
RL allows the system to learn through trial and error, optimizing recommendations over time based on the long-term impact of suggestions on user engagement, not just immediate clicks. It's about learning a policy for making good recommendations dynamically.
Interesting. The document also mentions personalization in a connected world. What does that entail?
It means making recommendations more seamless and contextually relevant across your life. Cross-device recommendations try to give you a consistent experience whether you're on your phone, laptop, or smart TV.
So if I add something to a cart on my laptop, I might see related ads on my phone.
Potentially, yes. And context-aware recommendations go further, factoring in things like your location, the time of day, maybe even your current activity, recommending a nearby coffee shop when you're out walking, for example.
Which leads towards hyper-personalization.
That's the goal for many platforms, yes. Tailoring recommendations down to the individual level, using a vast amount of data points and context signals to make predictions that feel uniquely relevant to you right now.
Okay, that level of personalization. It sounds powerful, maybe even a bit spooky. This brings us to ethical considerations and user trust, which seems incredibly important here.
Absolutely critical. As these systems get more powerful and pervasive, the ethical questions become more urgent.
Like privacy, for starters, all this data collection.
Exactly. How is user data collected, stored, used? Is it secure? Are users aware and consenting? Regulations like GDPR and CCPA are trying to address this, but it's an ongoing concern.
And what about bias in the algorithms?
A huge issue. Algorithms learn from data, and if the data reflects societal biases, the recommendations can perpetuate or even amplify them. This can lead to unfairness, like certain groups not getting shown job opportunities or reinforcing stereotypes. Ensuring fairness and representation is a major challenge.
Then there's a whole filter bubble or echo chamber effect, right?
Yes. If systems only show you things they think you'll agree with or like based on past behavior, they can inadvertently limit your exposure to diverse perspectives and information. This has potential consequences for individual understanding and even societal polarization.
So how do we counter that? More diversity?
Promoting diversity in recommendations is one strategy, but also transparency and explainability are key.
Being able to understand why something was recommended?
Precisely. If users understand the logic, even partially, it can build trust. Explainable AI, XAI techniques are being developed for this, and giving users more control over their data and preferences is also vital for building trust.
Right, letting me tweak settings or say, don't recommend things like this.
It's about empowering the user and being accountable. Platforms have a significant responsibility here.
It also seems like pulling in ideas from other fields could help, like the interdisciplinary integration mentioned.
Definitely. Understanding why people choose things involves more than just data patterns. Insights from behavioral economics on cognitive biases, or from psychology on motivation and how preferences form, or from sociology on social influence, all can lead to building more nuanced and human-centered systems.
So looking even further ahead, what about emerging technologies?
Well, we mentioned conversational systems and XAI. Federated learning is interesting. It's a way to train models across many devices without the raw user data ever leaving the device, which is great for privacy.
So the learning comes to the data, not the other way around.
Kinda, yeah. And way down the line, perhaps quantum computing could eventually offer breakthroughs in processing the complex calculations needed for very large-scale systems. But that's still quite speculative for now.
Wow, okay. So wrapping up, it's clear these recommender systems are, they're incredibly complex engines driving a lot of our online experience.
They really are. They use a mix of techniques, content, collaborative, hybrid, and others, each with trade-offs. And they constantly grapple with challenges like cold start, sparsity, scalability, and now increasingly ethical concerns.
And the future seems to point towards even smarter, more deeply personalized systems powered by advanced AI, but hopefully with more user control and transparency built in.
That's the trajectory, yes. More sophisticated, more integrated, but also facing a growing need for responsible design and deployment.
So a final thought for you, listening. Take a moment to think about the recommenders in your life. Your streaming services, shopping sites, news feeds. How well do they really capture your tastes? And maybe more importantly, what unseen influences might they be having? Are they broadening your world or subtly narrowing it? It's definitely something worth pondering, how much we let algorithms guide our choices. Thanks for joining us for this deep dive.